You know, nothing ruins a stunning million-pixel LED presentation quite like a visible seam. It's the first thing your eye goes to, right? Well, welcome to this explainer. Today, we are mastering end-system LED troubleshooting so you can ensure your screens always look absolutely flawless. We're going to focus heavily on dark and bright line adjustment. This is just a totally critical skill for correcting those uneven brightness lines across LED displays, which, as we'll see, usually pop up due to driver IC timing issues, data mapping errors, or calibration mismatches.
So here is our roadmap for today. We are breaking this down into three simple parts. First, the visual problem itself. Second, the hardware setup. And third, the software configuration. All right, let's jump right into section 1, the visual problem. Now, if you work on rental sites, you know that modules are constantly being coupled and disconnected. It's just the nature of the beast, making physical gaps practically unavoidable. And the physics here are pretty straightforward. When a physical gap between boxes is just a bit too large, it pushes the adjacent LED beads too far apart, and boom, you get a noticeable dark line. On the flip side, if you squeeze those edge beads too closely together, they form a bright line. It's literally a microscopic spacing issue causing a massive visual distraction.
But it's not always just a physical gap. Beyond the hardware physically sitting wrong, electronic culprits are often to blame here. For instance, you might encounter faulty driver ICs that are literally forcing certain rows to over-illuminate. Or maybe you've got damaged or loose flat cables interrupting the signal. But very often, it's actually a hidden software mismatch. Things like incorrect scan timing, or maybe you mix different module batches in a single screen setup. Any of those can result in those dreaded horizontal or vertical artifacts.
So, how do we fix it? Well, our adjustment process essentially acts as a highly targeted calibration. By fine-tuning the brightness of just those specific edge beads, we can practically erase the seams. Now, as a best practice in the field, you always want to use a colorimeter or a brightness meter first, just to measure the luminance across the rows before you start tweaking. And keep this in mind, if the physical misalignment is just way too severe, all the software in the world won't save you. You're going to have to pull out a wrench and physically revise the setup.
Which brings us nicely to section 2, hardware setup.
Okay, so to get this fixed, your required hardware path is a very specific daisy chain. It's like a pipeline. You start with your main control computer. That connects via a standard network cable to your remote computer. Then, that remote computer acts as your bridge, linking directly to the sending card. And it uses both a USB cable for the data and control side of things, alongside an HDMI or DVI cable for the actual video signal.
Now, because your remote computer is usually sitting right up next to the display hardware, maybe backstage or up on a rig, you'll absolutely want to manage the system remotely from your primary control station. To set that up, it's super easy. Just hop onto the remote computer's desktop, right-click My Computer, click Properties, and then hit Remote Settings to enable access. Literally 3 simple clicks, and your remote command center is fully operational. Trust me, this saves you from running back and forth across a massive concert stage all day.
Now for the fun part, section 3. Software configuration. Let's actually execute this fix. Before you go wildly adjusting sliders, you really need to understand a couple of core parameters. First up is the shift clock frequency. This basically dictates your pixel array size and your refresh rate, all based on what your driver chips can handle. But crucially, you also need to monitor your OE, that's output enable. The OE timing directly controls the exact duration the LEDs are actually lit up, which makes it your absolute primary lever for fixing these brightness lines. And closely tied to that shift clock is your DITA duty, which is the duty cycle for the shift clock itself. Now, as a general rule, this is usually kept at a stable 50%, but manipulating that OE duty cycle is exactly how you perform the magic. You can reduce that excessive luminance to fix a glaring bright seam, or you can increase the row gain to rescue a dark line.
Here's a huge pro tip. Always utilize the software's refresh function before making changes. This pulls the current hardware info and verifies if your ScanBoard programs actually need an update. Seriously, a massive common issue we see out in the field is a simple calibration file mismatch. If your software and your hardware are out of sync, your adjustments are either going to map completely wrong, or worse, you'll cause the whole screen to start flickering. Nobody wants that.
Okay, so in your Nova LCT software, you're going to navigate over to Tools and select Quickly Adjust Dark or Bright Lines. This is where the actual mapping happens. You can assign correction coefficients to specific rows or columns. You can manually tweak that OE timing we talked about, adjust your gamma curves, and even group your cabinets by rows so you can correct them individually. And once you think you've got it dialed in, best practice dictates verifying the fix. Run full, pure red, green, blue, and white test patterns across the screen to ensure absolutely zero visible seams remain.
Which kind of leaves us with a fascinating final thought to ponder. We've just walked through how meticulously manual this whole process really is, right? You're measuring luminance with colorimeters, carefully mapping coefficients, and tweaking OE timing by mere clock cycles just to trick the human eye. But as AI and camera-based algorithms get increasingly sophisticated, you have to wonder, will a master technician's trained eye always be the final judge of a perfect display? Or are we quickly approaching a day where we just trust the machine to flawlessly balance its own gamma curves? Definitely something to think about. Thanks so much for joining me on this explainer, and I'll see you next time.